You're good. You're the nice guy. Hey, Andy Stewart. I'm from Cisco, retired Navy captain. Was commanding officer of Navy Center Warfare Development Group. It's the best job I ever had in the Navy. That job to be the N3 for record building at Fleet Cyber Test Fleet, which was one of the hardest jobs I ever had in the Navy. I'll just say that because I'm about 6'5", I have nothing here. I joined, and this is so awesome to have Mike Younkers with me. Mike, can you give me a quick intro?
I can. I'm Mike Younkers. I'm the Director of Systems Engineering. I work with Andy at Cisco. I've been at Cisco for a long time. Before that, I started my career in the intelligence community. Just glad to be here to watch Andy present, and I'm going to flip the slides for him.
He'll be doing more than watching me present. He'll actually get us into the code section of this. Next slide. Yes, sir. So this starts with the need, and I'll say. This is all happening in DoD these days. And, how do we actually make applications from a DevSecOps, help transform mission and do good things? Platform One, great example. All the stuff, follow Nick Shalon, some of the stuff they're doing, building these pipelines, are really awesome. And when I was at NICWEDGE, I had these kind of guys working for me, Samuel's working for me, doing amazing, I'll just say badass stuff. And it's really about transforming the mission. But one of the things we found out at NICWEDGE was the guys who did this kind of development were really good at building those tools. They absolutely sucked at running the network. And actually was kind of took away from their time doing those tools. We brought in the N6 to help them run the network because that's hard. And why was that hard? Because managing infrastructure, has not really changed much over the last 30 years. And nobody says, hey, look, we got this sexy thing happening here in the community. And this maybe not look so sexy, but it can be sexy and it is sexy, and that's what we're talking about today. And I think it's really important, especially when you think about the scale and speed, the way these guys are going. We'll talk about it. This has got to come along with it. It's about raising the game. This is why I'm excited talking to you guys, cyber professionals who are going to make that happen. Next slide. So why model-driven DevOps for doing NetOps? And the Military Cyber Professional Association, graciously published my paper in Cyber Magazine. So if you want to see it in detail, it's all there. But I think. When you see the big things that are happening in network ops today, you have this software-defined abstraction that allows this for the apps and the network. I'll talk a little bit more about that. But the operating space is becoming more and more complex. And so the ability to scale at speed is now a mission imperative. It is a hybrid multi-cloud environment, certainly for managed cloud in the DoD space. I think when you think about how fast these new software factories and applications are going to be coming out. It's going to create more security requirements. It's going to require more agility on the part of the network operators. And we already said that's about mission transformation for the applications. So the network can't be the thing that slows down. In fact, it has to be the mission enabler. But for me, and this is really where I come from being the Fleet Cyber N3 guy, it's about how to actually take commander's intent, encapsulate it, and allow the network to move at speed and scale. That gives me things with advantage. So I can now create, say, wartime modes of operating. I can create and present options to a commander that are tested and secured and implemented at speed. So, kind of goes back to the transformer repairs, and this is absolutely necessary for the community. It's a community challenge. The background sort of. Kill that slide. Okay. Something in the email process. So why do people push back? The first thing is complexity. It may seem complex for a NetOps guy saying, what you're talking about in terms of network as code sounds really complex. I really just feel a lot safer with my command line interface. But actually, as you'll see in the examples we have coming up, it reduces complexity. It allows us to act, and when we start thinking this way, it starts changing the thought of the community. The next thing is keeping things running, which is, I just want to make the network keep running. I don't want to cause problems in the network. I don't want to cause perturbation in operating things. But that doesn't mean you have to do that in a manual way. In fact, taking this approach allows us to transform those kind of operations, and that you know that they're tested, and when you bring those changes in, that they will succeed. Lack of understanding of the source of truth is sort of this next thing. The source of truth really starts becoming this digital twin. And so the source of truth isn't what's in production. The source of truth is actually what exists in the network today. It's sort of like, when you go to flight school and say this is the fake horizon, it's actually more accurate than the real horizon. Same approach. If it doesn't exist in the network twin, the digital twin, then it should not exist in production. I think when you get into testing, simulating testing is critical. You'll see that when I hand over to Mike in terms of what that means for CI/CD. That be able to test in a representative network is critical, and so you have to actually have those tools and capabilities. This really gets to how do you start creating change in a culture. And part of it is managers listening and understanding the need. So why I'm talking today. When I was a manager in Nickledge, learning, hearing what the operators need. This is what the operators need, and then setting the conditions for their success. That could be getting them that training environment, getting them the tools and the training. So, next slide. I hope this is it. We're going to walk through, this the steps for DevOps, but DevOps is not the goal. I've already said it once. Mission transformation is the goal. You'll see how we start from start small, hands off the keyboard, bring in automation, bring in the simulation testing, the digital twin, and actually getting DevOps and working in a way that's more efficient, more secure, allows us to maneuver the network at speed, but the goal is so that enables mission transformation. DevOps is not the goal in and of itself. So what's enabling all this is abstraction. And I wish I knew more about software-defined networking when I was the N3 in cyber. I can tell you, I didn't realize the power that abstraction really brings in terms of how do I operate the network, how do we secure the network. And now that you have these capabilities in modern network, you can begin to render the network as a collection of these APIs. A lot of words on the slide, I know. But think of it as a goal of rendering the network in forms of data that I push through known APIs to the network devices themselves. And so when you think about that, your infrastructure really is the code that sits up at the top and you push into the network devices. But notice the APIs go up and down. So if the change happens down here, I should be aware of it on top of it. In fact, that is one of the advantages of moving to network ops this way. Because if somebody maybe does something wrong down south on the device, if it's their fingers, one of those people that couldn't give up their CLI, I'll actually know, and I can enforce that at speed and scale. See how we're doing it? So, what is DevOps? I think of DevOps really as an organizational strategy more than I think of it as the tools. We're going to talk about tools. Mike's going to talk about code. You're going to see Yang. You're going to see really cool, geeky stuff. But I think of it more in terms of it's an organizational strategy that enables mission outcomes. So when you have DevOps, you have a culture. You have people who actually have the processes and tools to do the reps and sets to actually begin to operate the network like this. So going way back to my SWO background, it's sort of like this is engineering operating system. We have naval aviation operating. This is the naval aviation's guy. This is NetOps, right? This is actually, I know how to operate the platform. I have processes and procedures that actually we inculcate that to the culture of the operators. That's what I think about when I think about what is DevOps. Next slide, Mike. So, and Mike's going to talk to this towards the end, but really the process is as simple as encapsulating the network as a data model, rendering that network into a digital twin, and then beginning to do repetitive testing that CI/CD process, and allowing that to be your means to deploy changes. So it exists in the digital twin first, then I bring it into production. If it doesn't exist in the digital twin, it shouldn't be in production. That allows NetOps to move at speed and scale. And again, I think it's all about capturing that network commander's intent and allowing us to have all the advantages that we want to have. Next slide. Model-driven DevOps. You'll see what this is. I switch out look like. But really, it's about a structured way to render the network into a data model. So it is all of these things in terms of being able to interact with those network devices, far better than doing it device by device through command line interface, right? In fact, once we represent the network as a data model, it is easier to then start rendering that code and pushing it into the devices via APIs. And the goal is no manual tasks. There should be no manual tasks on those network devices once you do that. Next slide. Oh, that hurts. That hurts. We'll do a handoff right here.
All right, cool.
All right, remember we talked about software-defined networking. And we had northbound, southbound APIs. She's taking a picture right now.
I'll delete that one and I'll just wait for it.
Actually, it's redacted. This is the unclassified version.
The full picture is in the magazine.
Yeah, the full picture is in the magazine. Oh, yeah. When you think about this controller, it's right there in the middle. That really allows the platform.
I get you.
That enables the platform. That abstraction is what allows us to push the data that's not the data models into the devices.
Page 15, month 5.
Thanks, Mike. And those devices can be of any type, of any brand, and certainly in that complex operating environment. And here's who actually will hand off to Mike, because he can probably do this with his eyes. Actually does this with his eyes.
Yes, we're going to dwell on this for a couple minutes, but before we dig too deep into what this really represents, I just want to do a quick survey of the audience. How many people here are network operators? Deal with the network. 1, cool, awesome. 2, cool. 3, awesome, cool. So this is really meant, this entire thing that we've been trying to drive forward is really meant to talk to network operators. But there's so many advantages to it. So how many cyber operators? Red teams, blue teams? Cool, awesome. How about cloud operations? I mean, we kind of operate in clouds. And when we do network and cyber, and then what about like actual developers, coders? Perfect. Okay, cool. So here's the Andy touched on this, and when he was kind of talking about what are we doing, and he got a little bit into the why, but I want to foot stomp this point. The why about the entire talk that we're trying to share with you today is the notion that right now the network is the thing that is holding us all back. If you want to do something in the cloud, you can fly as fast as you can get it done. You can automate everything. You can use templates. You can build pipelines. You get everything you want to get done in the cloud, hybrid clouds. You can do it on-prem. You can do it with systems. You can do it with storage. You can do it with advanced AI type things. The one thing you cannot maneuver very easily in a powerful sort of automated and certainly in a pipeline kind of way is the network. Now, I work at Cisco. I've been there for 22 years, minus a couple of years when I stepped aside to go do a small cyber startup kind of thing to learn the cyber industry from the inside. It pains me and it hurts me as a representative of Cisco and as a network engineer to think that we're the people that are slowing down mission transformation. So 4 years ago, the team that I run, I built a little tiny DevOps team inside of my network team at Cisco. And the journey we embarked upon was to say, you know what? We should not be treating the network any different than any other part of the IT stack. Why do we allow this to happen? Why do we still have network operators going out there and touching, SSHing into boxes and doing CLI kind of stuff? So this picture is actually represented in the small here, how that bigger one was supposed to come through. So let's just rip this apart for a couple minutes, because the people who are doing development and understand notions of CI/CD pipelines and or DevOps, like this is going to make a lot of sense to you. But for the network operators in here, if you haven't leaned into this and embraced this yet, this stuff looks like just stupid boxes with some lines between them on a chart. For years, that's what it meant to me. Software-defined networking,
don't go yet. Software-defined networking is what enables this, and we'll come back to this in a second. But what are we doing here? Basically, what we're doing is we're representing the network as a model, as a data structure. So the computer scientists in here, right? We're finally starting to treat the network properly from computer science best practices and principles. We can represent the network as a data structure. We can stop, to Andy's point, having this source of truth, which is what are our subnet masks? What are our IP addresses? What are our access control lists? What does our BGP routing table look like? Right now, most networks, if you want to know the answer to that question, you got to log into a network device and do a show running config. It might not even be the one that's stored in memory. It might actually be the one that's running, I'm sorry, that's stored in persistent storage, right? It could be the thing that's running in memory, and when that thing takes a power hit or a recycle, or, you know, the austere environments that we all operate in, and those things, you know, they are pets at this point, not cattle, for a true DevOps kind of term. When those things reboot, who knows what state they come back into? God help us when we want to do a CCRI, right? Like we are on the network side, we got a lot to do. So step one is represent and notionally understand that the source of truth of what's going on in your network ought to be off the network itself. You should not be dependent on what's running on the devices in the network. So first powerful piece here is let's get the source of truth outside of these network devices that are represented down here, right? Let's pull it out. Now, once we do that, and we represent it as a data structure, now we have the sort of underpinnings of infrastructure as code. We can all look at that, we can deal with that, we can model it, we can do stuff with it. To Andy's point later, we're going to talk about simulation, which is really cool. Okay, so the source of truth is like the single most powerful thing out of this entire thing. If we approach the fact that the network should be just like every other part of the IT stack, and then we recognize the fact that it has APIs, so we can actually program them in a different way through an API instead of CLI, then we pull the source of truth out. So then we can run these really cool, everybody familiar with the CI/CD pipeline? Yeah, the benefits of all the coolness of CI/CD pipelines. Right now, if you buy a Cisco network from us, you aren't likely running a CI/CD pipeline on how you build that network. And we're no different than Arista or Juniper or Brocade or insert your favorite network vendor, right? We're all the same. So this model-driven DevOps really was, you know, let's go push the envelope. Let's take advantage of what we get available to us because of software-defined networking, and then let's go operate like everyone else in the IT industry does. So we have these network devices down here. Andy called out this thing of abstraction. I went to the University of Maryland, not too far away from here. I went to school to be a network engineer, and I'm so old, there was no network engineering thing, so I started out as a double E. I ended up as a computer science. The main key takeaway I learned in computer science is abstraction, right? Stop rewriting code over and over and over again, write it once, make it generic, and use it for lots of stuff. So what we're trying to do is abstract the network from the higher level. Look, this is an ITSM system, whether it's your own home role ITSM or it's ServiceNow or, you know, insert your favorite case management. Imagine, instead of us just talking about opening cases to test a new operating system on a network device, I think we could really do it. We actually can do this now. So the idea here is build some abstraction so you're not going straight from a human operator into the device through SSH. So let's go ahead and move forward. I'm talking fast because there's a lot to get out here, and we're not going to get through all these slides, but it is written in the article. So here, Cisco, that's us. Here's Juniper. The point of this talk and the way we build model-driven DevOps, even though we are at Cisco, this whole thing is multi-vendor. It's open, it's extensible. None of this in here is meant to lock you into any particular vendor. And it works in software, virtualized devices, and also physical hardware instantiations. It does not matter because of the way we're treating the network. This just happens to be a snippet of BGP. Okay, those two things look really, really, really different at a high level in how Juniper builds their BGP route tables versus how Cisco does it. But look, it's the same information. Right? You got an autonomous system number, you got some IP addresses, some neighbors. It's all the same stuff, right? So the first thing we did was, go ahead, Andy. We represented, and not we model-driven DevOps, I mean we the industry represented network stuff as a data structure, and the open way to do this is called open config. It's, Google kind of started it, it's open, it's out there, all the web scalers use open config. So we're not talking about a Juniper native model or a Cisco native model. We're talking about an industry standard open config called open config. That's incredibly powerful because you don't know where you're going to end up tomorrow. You may have to drop some virtualized network function on a general purpose compute in a sub under the water, and who knows what, what piece of device that is, right? Who cares? Because what we need are the ability to build BGP connections, not, know the nuances of how you program a specific Cisco device. I'm generalizing this because this is giving us those abstractions, right, that are allowing us to do powerful things. Okay, so cool. So we used OpenConfig, so it's open source. Let's keep going, Andy. And then the abstractions, these give us the powerful things. This happens to be a tool because in the networking industry right now, not a lot of networking devices actually speak OpenConfig in a useful way. So us and some of our peers in the industry are trying to expand OpenConfig for the things that we think are important. But until we get there, we need some layers of abstraction. There is a platform called Network Services Orchestrator that we have at Cisco. It was our tail left acquisition. If you were tracking what we've been doing over the years. Again, this is not a product pitch, and I'm not trying to convince you need NSO. What we need is an approach to model-driven DevOps and the notion that we can abstract things away from the underlying hardware.
How do you know?
I thought there was a question, that's just in the hallway. You have 9 minutes left, right?
Yeah.
Okay, cool. So, OpenConfig services. I'm just gonna blow through this really quick. The notion is we build services like router BGP. That's just a concept of a service. Okay, so we go build things. It's not unlike an EC2 instance in AWS that you represent virtually. So let's keep going, Andy. Okay, so we're probably going to stop here. I'm most likely going to run out of time on this picture, but that's okay because this represents everything that is powerful about what we're doing. So if you're buying into DevOps, and oh, by the way, the reason we picked DevOps is because everyone calls it something different. DevOps, NetDevOps, DevSecOps, right? Pick your favorite term, it doesn't matter. It's all bringing together development and operations in a more powerful way. Another side story I'll tell you, I told you I got an education as an engineer and a computer scientist, but I was raised by techs in the intelligence community, and they never liked engineers touching the network. They always did the screwdrivers when we showed up. So I felt like I got the best of both worlds because the techs taught me how to do actual things while we were in the ivory towers as engineers trying to design stuff. Well, what I will tell you is when I graduated from college and my first assignment I worked at CIA, I can tell people that now. My first assignment at CIA was, there's a bunch of network elements over there. Here's a new operating system. Here's a test plan. It was like 4 times the size of this magazine. Go test that code and tell us if it breaks anywhere along the way, right? We had a well-defined test plan. So what I do, day after day after day, 8 hours, I go in and I'm running through this test plan. A week and a half into it, boom, something breaks. Oh, well, now we got to go file a ticket, open case. It leads to a defect, it gives us a new line of code, so, I go get the new operating system for this network device. What do? I go all the way back to the beginning and I start over again. What a waste of government money. But this is what we do in the networking industry, right? So let's take that as an example, and we can make fun of me all you want. And then let's lay it out. Like, this is DevOps as it applies to the network. So we get some change in workflow. My branch chief comes in and says, Younkers, get your butt in the lab and go test this new operating system. Okay, cool. So there's some change in workflow, a change gets requested. Now we have tools. And I don't care what these tools are. We're showing Jenkins here. Here's your favorite, CI engine. It doesn't matter. We're doing a lot of GitHub stuff now, but it doesn't matter. Just use a tool to run an engine, right? So boom, all of a sudden we hit this automation engine because it detects a change. New operating system got posted to Cisco.com last night. Let's go test it and see what happens, right? This whole thing's automated. There's no, like Younkers sitting in a lab somewhere. Pulls down the operating system, kicks off the test. Now here's the power of the source of truth. I can represent my entire production network, virtually or physically, doesn't matter, it can be both, right? It doesn't have to be virtual, but boy, it really is cool when I go take advantage of someone's infrastructure as a service, whether I build my own or use a public cloud provider, who cares? I have infinite compute to build my production network. The other problem that I had when I started out as an engineer is we could never properly represent a global network. The CIA is a global network. I could never get that many devices in our lab where I was working, right? You just can't do it. Well, in a virtualized environment with infrastructure as a service, I can build out as much as I want. So now all of a sudden, I go build this virtual test, right? And I take the source of truth, the actual source of truth that's running in my production network, not a sample of it, not a subset of it. I can take the entire thing and go push it in a virtual environment, build my lab with all my test cases underneath of it, and run the tests, and then produce a result, right? And drop it in chat ops or something. So when Mike Younkers walks in the next day, I look at what's in the chat room and I go, oh, the test passed. So if for some reason
an IAVA or something comes out, we need to upgrade the operating systems on these devices. I know that that particular one is good because I've built my network virtually and I've tested it against all my test cases. So if the commander comes along and says, we have this IAVA and we want something done, you're going to get a change window, midnight 2 days from now, I can have a higher degree of confidence, it's not always 100%, but I can have a higher degree of confidence that I'm ready to go. And as you guys know, because you know about CI/CD pipelines, the part I'm talking about right now is CI. If I choose to, I can automate the CD. I can have this thing deployed automatically on my behalf if I want. And we don't suggest that at this point in time. We actually think that there's a really good place to put humans back in this loop and decide when, where, how, and why to upgrade things, particularly when you're dealing with IAVs and stuff, to make sure that you have the testing around it, that you're actually addressing the problem. So there are places where you can insert humans, but you don't have to, and put these things here and push these things out in a CD environment. So if I talk about automating disastigs, and I have this notion of the ability that disastigs are machine readable as we partner with DISA and drive these things forward, why can't I, before I try to make a change to the network, run something that says, yes, you're not going to violate the stakes by making this change. So, the branch chief comes in up here in ServiceNow and puts in a ticket that says, we need to do some new service. Okay, cool, we're going to run that service through this process. And over here, we have a stig module that checks to see if we're going to break the stig or not, right? So now my CCRIs are not like, hey, get ready for this, not prepared for this. I never get my network in a state where there's a problem to begin with. All right, so Andy, we'll go forward like a bunch. So there's a framework to get this done. There's a bunch of steps we recommend, because if you're a network operator in here, all this stuff might sound like, gobbledygook nonsense that I'm throwing at you with a bunch of buzzwords in it, so you gotta know where to start. So we have a process, right? The goal is mission transformation. The process is understand your infrastructure is now consumable. All network elements have APIs. Cool, understand that, take advantage of that. That in and of itself is a culture change that has to happen inside the network industry. But then we can, pull that source of truth out of the network. We can start taking advantage of infrastructure as code. We can build pipelines along the way to take advantage of those things. And then boom, all of a sudden now we have commander's intent. All right, so let's keep going. I'm about to wrap this up. So we have right here, we have proposed architectures, how you get this stuff done. And then finally, again, for the network operators, here's the lesson I've learned in the last 4 years. My head hurts so much because we've been banging it against walls, trying to convince people that this is a good thing and a proper thing to do. I told you I started at Cisco in 2000. I'm old, right? I was there when Cisco was disrupting the voice industry, and we were driving voice over IP. And Nortel and Lucent told us it was never going to happen. They're like, you're never going to put voice in the data network. Well, 22 years later, we all know where we are, right? Unfortunately, the network industry right now, we are the Nortel and Lucent. Like, if Cisco, we're not careful. When I go back in time 22 years ago, like, I got this existential threat coming at me as a Cisco representative, right? Like, we got to get with the times. But if you're a network person, if you're a network engineer, a network operator like I was, I'm a manager now, you don't really embrace this stuff yet because it's all foreign, right? We've been doing what we've been doing for 30 or 40 years and we don't want to change. But when I go talk to senior leaders of organizations, they want change more than anything, right? CIOs, whatever, commanders of things want to drive forward. The CIO of the Air Force talks about software factories and pipelines all day long. Is she talking about the network? No, right? That's the thing we have to change. So I know this is a big change. It's a culture change. So we have DevOps workshops for anyone who wants to do them. Find me on LinkedIn and I'll get these available to you for free. This is not, we're not trying to sell things here. We're trying to push the industry forward to do stuff. And then finally, because we got tired of telling the same story over and over and over again, the engineers underneath of this, Stephen Carter and Jason King, and then with some help from Josh Lothian, they were kind enough to let me stick my name on this. We wrote a book. So if you're interested in digging deeper in this, there is a book. It's coming out in August. Again, I'm not trying to sell it. I'm just telling you that it's there as a reference. And then the final thing I'll say, anybody who loves GitHub, we have a GitHub repo. It's literally github.com/model-driven-ops. model-driven-DevOps, and I know that's confusing, so find me on LinkedIn. It's Mike Younkers, Younkers. I'll get you the repos if you want to dig into them. And there are exercises in there that are kind of some of the underpinnings of some of these workshops. So, Amy, I'm sorry, I consumed the rest of our time, but I want to give it back to you to close.
grab us for questions afterwards.